Good morning. Looking at the last section of chapter 4 today. This is 4.8. We're going to look at working with mixed numbers and order of operations. So kind of a combination of most of the things that we've studied this semester. So the first one we're doing 1/5 plus 1/2 times 1/4. So the thing we want to remember here is that according to order of operations, I want to multiply before I add. So also remember, when you multiply straight across. So for this first one, we get 1/5 plus 1 times 1 is 1, 2 times 4 is 8. Now we have 1/5 plus 1/8. We need a common denominator. Five and 8 have no numbers in common, or no factors in common, so the LCM is going to be the product of those two numbers. So we need to get here a 40 in the bottom. So this first guy is missing the 8. Second one is missing the 5. Simplifying that, we get 8 times 1 is 8 over 40 plus 5 over 40. Now that we have the common denominator, we can add the numerators together. We end up with 8 plus 5 or 13 over 40. And that, my friends, is our final answer. So there's the first of our 5 or 6 examples today. So the first few here are going to be very similar with slightly different twists. Here we're working with several negative signs and subtraction. We'll start by rewriting this problem. -1/12 minus 2 times -5/8. So again, we'll work with the multiplication first. And remember, when we have those parentheses and no symbol in between the 2 and the -5/8, that implies multiplication. So we have -1/12 minus, in this case, we get 2 times 5/8. Let me run off to the side here and work that. So we have -2 times -5/8. Just remember, we can divide this by 2 and this denominator by 2. So we're really just simplifying this fraction, putting it in lowest terms. So in that case, we would get -1 times -5/4. Well, the two negatives will give me a positive when we multiply, so we'll end up with 5/4. So this will be minus -5/4. So subtracting a negative would be the same as adding. So we get plus 5/4. Again, we need a common denominator. In this case, it's going to be 12. So we need to multiply the top and the bottom here by 3. And then we end up with -1/12 plus 15/12. In order to finish that, we have -1 plus 15 is 14 over 12. And again, we can simplify that. We can divide the top and the bottom by 2. 14 divided by 2 would give us 7. And 12 divided by 2 would give us 6. And we end up with 7 over 6. Next problem. Now we're adding a little bit of exponents in here, so let's deal with this. Let me rewrite it first. 3 over 5 squared minus 1/5 times 1 and 1/17. I'm going to start by doing the square. So remember, using order of operations, we would do parentheses and exponents first. So 3 over 5 squared is going to be 9 over 25 minus 1 over 5. And then changing this to an improper fraction, we would get 17 times 1 is 17 plus 1 is 18. So we have 18 over 17. So now it looks like the first couple of problems that we did, we'll work with our multiplication first. So, minus 18 times 1 is 18. 5 times 17 is going to be, well, 5 times 10 is 50. 5 times 7 is 35. 50 plus 35 is 85. Now we have to deal with subtraction. We need a common denominator. It looks like we have a 25 and an 85. So let's work off to the side a little bit and refresh you a couple ways. So we could do this by doing a factor tree. So that would be 5 times 5. 85. Well, we can take a 5 out of there. 5 goes in there. 5 and 17. So again, using that technique, I want the largest number of times each factor shows up in any one of the two numbers. So we have 2 5s and 117. Well, the 25 has the 2 5s, but not the 17. So we'll multiply the top and the bottom by 17. 85. Well, 85 is made up of 5 and 17, so it's missing just one of the 5s. So we will multiply by that missing factor of 5. Okay, let's work on that. So 9 times 17. Well, 9 times 10 is 90. 9 times 7 is 63. 90 and 63 is 153. So we get 153 over 17 times 25. Well, 16 times 25 is 400, right? Because there's 4 25s in 100, so 16 would give me 400. 17 would give me 425 minus 5 times 18 is 5 times 10, which is 50, and 5 times 8, which is 40. So that's 90. And then 5 times 85 should give us 425 again. And that gives us our common denominator. Okay, 153 minus 90 is 63. And we keep our common denominator, 425. Let's see, 425, 9 to 11, so that looks like it's in reduced form. So we'll leave it as a fraction. Let's look at the next. Okay, so similar problem, slightly different look though. So So this is written as what we would call a compound or a complex fraction. So it's a fraction divided by a fraction. These turn out to be typically pretty straightforward though. So we're going to use one property which we will discuss in just a moment. So hopefully we remember that if you divide a number, so if we had a divided by b, that's going to be the same thing as a times the reciprocal of b. So a times 1 over b. So in this case, we can rewrite this as a multiplication statement, and we're always going to write these complex fractions as their equivalent multiplication statement. So we have 2 over 3 times the reciprocal, or 1 over b. So the reciprocal is going to be 3 over 5. Because we have a 3 in the top and a 3 in the bottom, we can cross-cancel those two factors. Then we simplify that, we end up with just a 2 in the top and a 5 in the bottom. So 2/5 is my final answer. And let's look. I think we have one more. We're going to have two more. This one's a little more complicated. So we not only have a complex fraction, but we have subtraction in the top and subtraction in the bottom. We got denominators of 10, 20, 5, and 20. So we're going to do a little work to get this one simplified. So we start off 1 over 10 minus 3 over 20. We're going to divide that by 1 over 5 minus 13 over 20. Okay, common denominator, 10, 25, and 20. Common denominator is going to be 20. So what do we do here? Well, let's see. We need a 20 here, so we're going to multiply top and bottom by 2. We have a 20 in the next one. Down here we need a 20, so we're going to multiply the top and the bottom of that first fraction by 4 over 4. Okay, let's simplify. So at the top we get 2 over 20 minus 3 over 20. We're going to divide that by, in the bottom, 4 over 20 minus 13 over 20. Let's simplify that as we can. 2 minus 3 is negative 1, so we end up with negative 1 over 20. In the bottom, we have 4 minus 13, which is negative 9 over 20. We have a negative divided by a negative, so the final solution is going to be positive. But we will rewrite this as a multiplication statement, so we get 1 over 20 times 20 over 9. And again, we can cross-cancel those factors top to bottom. There's a 20 in the top and a 20 in the bottom. Once we do that, we're left with a 1 and a 9. So our final answer here, after all that work, is 1 over 9. And we have one last problem. This will be the final problem for today. This covers chapter 4.8, doing order of operations with mixed numbers. Make sure to send me an email. Let me know if you have any questions. We'll follow that up with some more examples or some more instruction. Here we're finding the average of 1/3, 1/4, and 1/2. So as you recall, to find that average, you add your numbers together and you divide by how many numbers we have. So we have 3 numbers here. So we will take 1 over 3. We're going to add 1 over 4. We'll add 1 over 2. And because we had 3 numbers, we will divide by 3. Common denominator of 2, 3, and 4. is going to be 12. So the first one, let's see if we can just squeeze this in. This one has to be multiplied by 4 over 4. The 1/4, we're going to have to multiply by 3 over 3. 1/2, we're going to have to multiply by 6 over 6. So again, we're just finding the common denominator. So the first one, we get 4 over 12 plus 3 over 12 plus 6 over 12. And don't forget that's all divided by 3. So let's move to the next step. We have common denominators, so we'll add the numerators. So 4 and 3 is 7, plus 6 is 13. We end up with 13 over 12, all divided by 3. Last step is to multiply by the reciprocal of the denominator. So instead of dividing by 3, we're going to multiply by 1/3. Because we're multiplying, we can multiply straight across. So when we multiply straight across, we end up with 13 times 1 divided by 3 times 12, which is 36. 13's prime does not go into 36, and so this problem is done. All right, so there's our daily examples. This is from section 4.8. Make sure you give me a holler if you don't understand, you have any questions, you need some more information.